Sutliff, Penn State Chemical Engineering graduate, year 2005. Currently work for Lonza Incorporated, and today we're going to cover the topic of problem solving, along with a little example. So now here we are back in the comfort of my office to talk about the topic of problem solving, and this is a very good skill that you're going to use every day in the industry as a chemical engineer. Most of the time you're going to be solving problems with either a process itself, so temperature, chemistry, how to make the desired product, or the process equipment. There's issue with a pump, a compressor, a turbine, what have you. Something's not working right. There's a problem to solve. So what we'll discuss now is kind of a general problem solving methodology I use and a basic flowchart that works you through solving a problem systematically, which is what we'll take a look at here next. So this is essentially the problem solving flowchart that I use, and we'll talk about each one of these steps here real quickly. So step one is define the problem. That's nothing more than a brief statement of exactly what's wrong. Also good to define criticality. Is it a safety issue? Is the problem causing an issue that has production down for some reason? That would get included into the problem statement as well. Step two is to do background research. Learn about the process or learn about the equipment that you're having issues with. Talk to some of the senior engineers, experts at the plant that have experience with it. Look up manuals, research files, all that good stuff to understand what should be going on. Next step, number three, is specify requirements. You have a problem. How should it be acting? What do you need to do to fix it? What's the end result or the goal that you're trying to achieve with the problem solution? Step four, brainstorm, evaluate, and choose the solution. So you come up with a whole list, involve several team members from the site, everybody who needs to be involved, to list out root causes of what could be causing the problem, how to fix those root causes, and what to go after in order to fix the situation, which then moves into develop and prototype the solution. So based on those lists of root causes, pick whatever will fix the issue, develop the prototype. Is it a new piece of equipment? Is it some process change, adjusting a temperature? And prototype it and figure out how that's going to be implemented. Next, step six is to test the actual solution in real time in the plant. See if it solves the problem, see if it doesn't. If it works, then you're done. Move right on, communicate the results to the pertinent plant members. If it doesn't work, if it fails completely or only partially works, it becomes kind of an iterative exercise back to all these other steps right here to arrive at a different prototype, a different test, a different solution. So sometimes this can be circular for quite some time until the definite root cause is identified and you can move into a successful solution. So that's the general basis and general flowchart for problem solving I use. Now let's take a look at an actual example. Here's our example problem. We have these particular pumps, and we put these leak detection systems on the pump mechanical seal housing, mechanical seal being the device that holds the process fluid into the pump as it operates. We never had issues before, but ever since we put these in, the seals leaked all the time, which is rather unusual. So we did a whole lot of work. We won't go over all this, but as you can see, a lot of work went into the problem-solving investigation, only at the end to find out a leakage rate of up to 3 milliliters per hour is acceptable for this seal. So, the seals were leaking all the time, but we never noticed it because the liquid would evaporate right away, and now we have these nice leak detection systems on here which are capturing the liquid, not allowing it to evaporate, and telling us we have a leak all the time. So, we had to solve the problem to account for the normal leakage rate for the seal, and we'll go take a look at how we did that quick next. Alright, here we are in the boiler room. Here is the pump in question. Here is the solution to the problem. An addition of a very small length of pipe to catch normal leakage from the seal that's allowed. What do? Out of this valve, we drain a small amount of normal leakage out every shift. That's how we solve the problem. Sometimes it doesn't always have to be that complicated. Hope you enjoyed the video.